Okay, we are hopefully going to figure out how to remove a whole stack of stones now. On a move type move, press an illegal move. We had, here, look, if we look in our click detection, we are doing this nested loop here that is unnecessary. We tried getting rid of it yesterday and it broke some stuff, but I was doing a little thinking and I think I realized what was going on, so we're gonna try it again here. Because we don't need to cycle through each grid, we just need to check if the mouse grid the mouse grid gets populated with the grid that we're on, so we're just asking upon a click, you know, whatever mouse grid we're on, that's what we're checking. We don't need to cycle through all of them. And then we could use I now, but we need to do this mouse Y, mouse X, and then see, because look, we had the code over here for the right grid index here. We're assigning. All this is doing is taking all of the current grid's stone. Actually, yeah, we need a loop. This is in a loop, so it's taking, for each occupant, it's taking each stone stack order, stone type, and stone color, and moving it into the corresponding field of our mouse stone members. So we're just duplicating our stack inside of our mouse stones occupant member or occupant instantiation, and then we're nullifying the place we clicked on. And then since this is when occupants is 5 or less, we become no longer occupied there. We become movement origin locked. So here we need to lock in the appropriate move lock is what we call it. Like, I guess, where do we use this move locks row? Okay, so we do this for all of the legal move highlights. So it's what we do to make sure we can do the arithmetic for the surrounding highlights, which is what messed up yesterday. Remember, we were highlighting the spot that wasn't clicked, and I think it was because I put the wrong grids here. So if row and column, I want to say X grid is the column, Y grid is the row, at least it should be. So if we put mouse Y grid, that is a number. Oh, I did that. Here, Y grid for the row. No. Fuck. Hold on. Yeah, the mouse X grid. Let's just, crap, I can't really run the code right now because I think it'll crash. But actually, it should run fine without clicking anything. Yeah. Okay. 376. Let's just, for right now. And that's what's weird about Lua. It's like, why did it fail there when this is in click detection, so it shouldn't have failed? So if we look at the first brackets, you know, 1, 1, and then this is 1, 2. So the second bracket is the column, first bracket is the row. So, what we do, we print up our Y grid, then our X grid. So first bracket was column, which this is maybe backwards. Because I feel like X should be the left and right, and Y should be the top down. Let me see. So yeah, we get an X and a Y. Then where do we put these grids? Where do we populate our actual mouse grid table here? Right here. Okay, I think this is... If you look at here, we first print out Y grid, then X grid. So it goes Y grid, then X grid. So if we just take a look at the first brackets, that's all the Y grids. 1, 1, 1. So Y grid is... This seems backwards to me, but mouse Y grid is row. So we'll put here under our click detection, we have a locked row, which needs to be the Y grid. And then move locked column, which should be the X grid. That seems backwards to me, but I calculate the grids based on the X position, so that's why I call that mouse X grid. As long as we have it right, it should work. That's like the stupidest thing I've ever said. As long as we have it right, it should work. Oh yeah. As long as everything's perfect, nothing will be wrong. Okay, and then we do... See, look, yeah, we populate Y grid first. That probably should be backwards, but this is how we've got it. So, what we're doing here is upon a click, we're moving all the stones into a mouse stones member. And then we are making this no longer occupied. We're locking in our origin locked. We move lock that grid, so that's the dark green, and then we lock in our locked row and column with the appropriate values for the next legal move highlights, and then we stop making our space a legal move highlight, which might not be necessary. I think I said that last time. I don't know exactly how that's working. I have to double check. And then here for the render, instead of rendering, let's just hard code in this where we render 3 members worth. We'll do this in a loop, but for right now, just want to see if it's working. So let's see if 1 stone can be taken out and then in the place of our mouse cursor. No. 488 index and no value. Really? Okay, let's see. That's really killing me that it always crashes there. Okay. See, because look, like, it crashed. And it crashed because it was trying to render a members 2 which didn't exist. So in the past, what we have to do is fill our members table with enough indexes of enough member objects populated with nil values so that we can leave that on render and have it not crash. But what I'm going to do is turn on this which gives us 3 stones and 3 occupants in our grid 1-1. And then I can turn these renders back on and we'll see if it's good. If we can move this stack, and we can't. 362. 362 is not liking. See, why does it do this? It's saying failure to index a nil value here. Now what's weird, now grid, so look, we'll make sure that our grid at 1-1 is 3 occupants, which it is. I checked it last time. Yeah, 3 occupants. So why is it that we can't access this with I? Why is that the case? Milestone members. Oh, you know what? It's because we don't populate our mouse stones with members. We need to, just like how we gave our, right here, we give our grid members, but we also need to give our mouse stones the same thing. Mouse stones.members at index k needs to get member instantiations of nil values, x and y nil, or no, stone type and color nil, and then x and y. I don't know. I don't want it to be on screen, so I'm tempted to just give it an x and y way off of screen. Would that still crash at the same line now? I'm curious. 363. Yeah. Same crash. And our mouse stones is members. Mouse stone members, yeah. At index, yeah. We give. Maybe we need to give it. Why? We need to do it up here. We need to give it members as well, I guess. Milestones.members at K. Give it. No, we already didn't. We just do this. What was the? Oh, we did it here. Okay. Okay, that was just in the reset. So maybe that was the fix. We just did it in the reset logic. Let's see. Crossed our fingers. Oopsie. Now let's see if we can take 3 stones out of grid 1-1 in a move type move. Oh. That's it. And they render the stack order. It's... Yeah. Yeah. You guys saw that, yeah? White. It goes white, black, white, white, black, white, and we've got the stack order. That's sick. Okay. That's awesome. That's really cool. That's a big deal. Let me just see what happens if we give ourselves a 0-0. Okay, still works. Okay. Because I don't think we're rendering, well, I guess we only render those if we're in a move type move and our movement origin locked. That's the only time we render those. So, I guess I want to print out and make sure that we have the correct occupants for our member, C for our occupant. So the thing is our mouse stones an occupant or a member? It is an occupant with a member's table. Okay, so we need to give our mouse stones table the correct occupant number upon a click, right? So I think we do that. We already do that. So where's click detection? Here. Then move, and then, yep. For every occupant in our grid, we increment our mouse stones occupant. So we should be able to, in our render, should be able to add this to a for loop where we can just say for I gets 1 for mouse stones dot occupants, do a render. Then instead of these 3 renders, we can just do the 1, and we don't render it at index 1, we render it at index I. And now we see if we can take 3 stones out of grid 1. Yo. Yo, yo, yo. That's nice. Oh, that makes me happy. Okay, I'm really glad we figured that out. That's what we failed to figure out yesterday. So yeah, we used to, so yeah, check this out. We used to, this was our old render logic, move type move. So jacked. We were just rendering a new, yeah, this wasn't even rendering the stone that was in the space. It was rendering whatever stone you happened to be selected upon in a place type move. So that was beyond jacked. But we've got that. We've got this. We can delete this. Okay, okay. Then we got to worry about placing. So we've got like, well, actually, we should probably work on how many stones to drop. So down on the keyboard would be drop a stone. So what needs to happen if we drop a stone is we see, and it gets different if there's more than 5 stones in a spot. But once our movement origin is locked and before we have our first move locked, I think that's what I'm calling it, we need to decide how many stones you want to drop. So down arrow would drop a stone in the move lock origin, movement origin locked, and then up would pick up a stone in case you drop too many. So we need to basically do the same thing we did for taking them out, but to put them back in, and only one at a time, and only upon a, you know, down key press. That's gonna be tough, but totally doable. We don't need this members 1 gets member because we actually do it right here. Oh, and look, we just give it a member. I wonder if we can do that instead of any of this junk. We just say give us a member, period, nothing, and we'll see if we can still take it out. Nice. So we don't have to worry about that weird stuff, because because that didn't matter anyway. At least, you know what I mean. So yeah, we need if movement origin locked and not first movement locked. I don't think we have a first movement locked logic yet. First movement. Yep, just one match. So, here in our mouse click detection, no, we can do it right after our mouse click detection. We would say, if the move type is move, and movement origin is locked, and we're not first movement locked, then we need to register those key presses. So if love.keyboard was pressed, love.keyboard was pressed down, then else if love.keyboard was pressed up. Okay. And this would be stone in movement origin locked. Then this would be pick up stone from. Oh. Okay. Cool. So what do we need to do? Well, you can only drop the first index. So this is tricky because we want to drop. Okay, if we okay, let's walk through this like one step at a time here. So if we press down and we need to drop a stone in our movement origin lock space, we need to remove from our stone. So look, we need to remove index 1 from our mouse stones. Okay. And then we need to add mouse stone index 1. This is probably beforehand. We need to add mouse stone index 1 mouse stone. I would say you can even do pseudocode where it's more readable. I mean, it's actually just real code at this point, but it's mouse stone member 1 into origin lock space, right? So we need to move the bottom stone into origin locked, but it's not members 1, it's bottom stone. And we have to specify that because if we remove it, then our occupant has only 2 members at this point, assuming our 3 occupant test group. So we want to drop shoot, yeah, this is just tricky. I should actually see how this 3D tech implementation does it. Not necessarily to copy how they did it, but to maybe they have some insight onto a better way of better order of operations than I'm doing. Kind of curious. But part of me wants to do it my way, you know, and then we can see what they did. So yeah, we need to take the bottom member. How do we do that? Bottom member would be index 1, and then it would be index 2. So maybe we have a variable in our members that is called bottom stone index. It doesn't, because that doesn't make a lot of sense, because the bottom stone index should always be 1, but not if we're moving it, not if we're dropping stones or picking up stones. So it's like we need a variable called bottom stone index or something. Moving bottom stone index. I don't know. It doesn't really make much sense. But let's do that. Let's give our members a field called bottom stone index. And it's not really the bottom stone index, because the bottom stone index of, actually, yeah, it's not in members, it's going to be in occupant, because we only want 1 for the whole group. So we would say bottom stone index. I guess we could just get nil first, and then if we press down our, actually I think it should start at 1. Yeah, because the default to bottom stone index is going to be 1. It's just that once we drop it, it'll become higher. So if we would need to increment the bottom stone index by 1, because what that'll do is we'll have 3. Index 1 is the bottom stone. If we drop it, we want to remove its stone type and stone color, so it doesn't render any stone, but we still need it to keep its same stack order, and still it needs to exist and not shift any indexes, so that we have the same render for our mouse stones. So yeah, once we drop a stone, then our bottom index will get incremented, then it'll be index 2, and then if we press down again, it'll drop the bottom stone, which is now index 2, which is that second stone, and then we would increment it, then bottom stone is 1, and then if we're pressing up, we subtract the bottom stone index, so we can repopulate the render, I guess. We have to kind of figure out how we do that. Shoot. But yeah, the logic is something like this, where we need to take that bottom stone, move it back into the origin space in its correct location, but in this case, this is only for actually, no, it's not. I was going to say it's only for occupants when it's less than 5. But that's not the case. That's only here in the move type move. Right here. So we'd have to figure out, or we'd have to make sure that can still work when we have more than 5 stones. So it's like we need a, actually our stack order, no, our occupants kind of works as our top stone index. It's just that I'm getting confused if we overwrite some of our occupant values, if we change, if we like, do we get rid of our members' values if we have less occupants than members, which I don't think we do. I think I'm just confusing myself. But yeah, it'd be something like this. Then we would like use occupants as top stone index. Yeah, and then we have to do some checking. Yep. And I guess it's not exactly that. It's that we cannot drop more than our stone's occupants. -1 actually, because I think we want to add an undo button sometime, but you can't, if you click on a move, you lock in that move. Like I'm not, and then you'd pick up, like, let's say all 3 stones, and then if you hit down, it would drop the first one, down, it would drop the second one, and then down, it won't do anything, because at that point you would just be not moving your stones when you clicked on that stone to do it. So I think I'd rather have like an undo button to, if you didn't want to move, if you change your mind on moving. God, it's so confusing. But yeah, this is the meat and potatoes of the game, and we're getting close. We can pick up multiple stones now. There's a little bit of nuance in the dropping of stones and picking up stones, and we need to figure out how to lock in our direction. We need to make sure we can only drop in legal move spaces, or just that the next move space is not a capstone or standing stone. And then we can work on an undo, or we'd work on probably win state before that, and then maybe add an undo if we're feeling jazzy. I don't know. But yeah, I'm gonna say that's a good little session. We take a look at our git diff. What we did was we added this bottom stone index for this new functionality of dropping and picking up stones. We took out our member instantiation or population, whatever you want to call it, and instead we moved it into our grid member instantiation, which makes a lot more sense. And then we actually, yeah, we'll fix that before we commit. We just want to populate this, not with this nil stuff. We just want to do it with an empty member class. And then we took out all our old logic for cycling through in a move type move. Instead, we just ask what our mouse grid is, and if it was a legal move, and if our occupants was 5 or less. And then that's where we do the substitution of stones into our mouse stones. And then we started adding the dropping and picking up stone logic, which doesn't function just yet. And then we look at that, we change our whole render. We changed our old render from that many red lines to these new, just, for loop, really easy. But before we commit, let's go to that reset and make sure it's an empty class right here. Then I just want to make sure it works before I commit it. Nice. That works. I also want to reset player upon a click. Okay, that's so nice that that works. So we'll get push, or no, get add everything to the staging area with a commit message saying we added ability to pick up stone stacks and then started to add stone pickups and drop-offs. Cool. I abbreviated pickups there because I felt we were getting close to the commit message max on what would show in one line on Git, so I kind of just shrunk it a bit. But yeah, we got some more stuff working today. We're still chugging along. I'm going to be switching back to Joust here as soon as I start kind of pulling my hair out over this stuff, so then we can pull our hair out over Joust again. But I will see you guys tomorrow, and we will code some.